Hello class, welcome to week 7 of Python 1 this again is chapter 6 is what we're going to be studying this week this chapter 6 is a lengthy chapter, has some concepts that are somewhat sophisticated for us. There will be a few things that we do not entirely cover in the chapter, and so you can consider what I cover in this particular lecture the content that you need to know for this class. So a function is, according to chapter 6, is a way for us to define a block of reusable code for and it allows us to organize our programming in such a way that allows us to not only reuse code, but helps us to be a little more efficient in the way that we lay out our code. So for example, say for example we want to develop a big program that requires us to do a variety of statistical tests, such as average, minimum, maximum, what's the mode in a range of numbers, what is the median in a range of numbers. So you could do this, you can use what we call functions to simplify our code by writing different functions for each of these different tests. And so, you know, we could write one big long program with a big set of if-else else-ifs. If we wanted to do that, we could do that. Or but probably the best way to do that is to write a different function and then call that function because when we write a function, typically we want it just to do one thing and then return the focus of the program back to where it was, what it was doing before we called that particular function. So the way that we define a function in Python is we use the keyword def and then the name of the function, and then in parentheses we have a list of our parameters, and we'll talk about parameters in a few minutes, and then we end the line with a colon. Okay, so here is an example of a function. We've defined a function called max, and it takes as parameters two parameters, number 1 and number 2. So we're going to pass two integers to this function. And again, notice that we have the colon after that, and then notice everything within that function is indented. Okay, and so here inside this function we say if number 1 that we've passed to the function is greater than number 2, then result equals number 1. Otherwise, result equals number 2, and then we want to return the result. And so what happens with this return statement is that it ends a function and it also returns a value back to that which called it. Okay, so basically what's going to happen is we're going to pass two numbers to this function, and it's going to determine which is the higher number. So if the first number that's passed is higher, then we have the result, but if number 2 is higher, then it's going to return number 2. To get there, we have to define what's called a main method, and we do that by using the keyword def and main. And main always is kind of the larger method that we're going to use to call all of our different functions. And so if you create a main method, you're going to use it and put all of your logic and do all of your method calls within it. Okay, so we say larger, or the larger of the two numbers, equals max 5, 6. Okay, and so what we're doing here is we're invoking this max function right here. It's expecting two numbers, a number 1 and a number 2, and so we've passed the number 5 and then number 6 to it. This is called, right here, this max 5, 6 is known as a function call because we're calling on the max function to be able to get the value of larger. And then simply we want to print out the number larger. Now on its own, these are functions. They can't really do anything on their own. But they're just sitting there because we've defined them as functions. We need to be able to call a function in order to execute either one of these. You know, so say for example, I don't have this text main in here, I'll just comment it out and we can see. And when I run it, nothing happens, okay? Nothing happens at all. Gonna run it again, you can see that nothing happens at all. But whenever I uncomment main, what it does is it calls the main method, and then the main method calls the max function. So let's see what happens whenever we run it. So we're passing 5 and 6 to the max method, and we should notice that the true happens with the else, and it returns the number 6. So let's run this, and indeed the greater of 5 and 6 is 6. Now we can change this around and pass 7 to 6, and let's see what happens again. And yes, indeed, it does return the maximal value that we are passing to this particular function. So very basically, this is a way for us to modularize our code to create smaller functions, smaller bits of code. And the neat thing about it is once I have created this maximum function, I can grab this and I can put it anywhere else in any other program that I have. It's reusable. I can use it anywhere else that I need a maximum function where we are comparing numbers to one another. Okay, pretty easy and helpful. Now, your book talks about you can return function, or you can have functions that return either have a return value or doesn't have a return value. And you notice that in our max function that we returned the value of the maximum value. But this is an example where we don't return a value. And so in this particular piece of code, we have defined a function called print grade. And we simply have some, you've seen this code before. If the score is greater than 90, then print A. Else if the score is greater than 80, print B, C, D, and all the way to F. Okay, so this function here, basically what it does is it prints out a user's grade. Then we've created a function called main, and we've said in that main method, we said that this new string called score is evaluate the value of the score. So say we enter 88 as the score. It's going to pass score. It's going to store that value 88 into the print grade function whenever we're ready to do that. So then the next thing is we say the next line we say the grade is, and then after that we do a function call where we call the print grade and we pass this value of score into the print grade function. Okay, so let's see what happens whenever we run this. Okay, so we're prompted to enter a score, and so let's say the score of the user is 65. Okay, what happens is it grabbed the value of the score, which is 65, and plugged this into print grade. Now, we could equally do this, and it's equivalent. Okay, or so by doing that, we could have put in the just hard coded that, but by getting the user input, we're able to hard code in that value, and there's no return value here. It just prints out what this particular function does is it prints out the value of score. Now we could do that, or we could also have a return value and see what. Let's look at that bit of code and see what it looks like. I'm going to comment that out, and then we're going to uncomment this piece of code, which is equivalent code, except it has a return value. All right, so in this we have a very similar type of thing, except we've declared a function called getGrade instead of printGrade. And in this it says if the score is equal to 90, greater than or equal to 90, then return the value A. For 80, return B. For 70, return C, D, and F. Okay. Then in our main, we ask them to enter a score, and then in the next line we say print the grade is, and then we're going to call the getGrade function and do and then pass the value of score into that. Okay. Then finally, we're going to call the main function, and main calls getGrade, and we should have all of our logic work out. So it should work out exactly the same as the other one. So let's look at it. So enter a score. We're going to say 65 again, and then again the grade is D. So both of these are equivalent, except that this one does not use a return value and this one does. So really you can kind of use it for whatever works best for you whenever you're programming, whether or not you use a return value. Now let's talk a little bit more about functions. They're powerful. We already talked about how we have the reuse value, and because it can be modular, but functions are powerful because they have the ability to accept parameters and then accomplish some task. And so when we call a function, we are passing what are called arguments to parameters. And arguments are simply the values that we pass to parameters. And in Python, we have two different types of arguments. The first type of argument that we have is called a positional argument. The other type is a keyword argument. We'll talk about keyword arguments in just a few moments. But for now, what you need to know is that positional arguments require that they be passed in the same order as their respective parameters in the function header. So let's look at a piece of code here, and let's look and see what it does. And we're going to comment out this, and we're going to uncomment this. All right, so in this case, we've defined a function called inPrintLine, and basically what it's going to do is it's going to print out, it's going to accept two different types of parameters. Okay, it's going to accept something called message and then something called in, and then we create a loop, a for loop, where we say for I in the range of n, print out the message. Okay, so what it's going to do is it's going to print out whatever we sent out as the message n number of times. Okay, very easy. So then we've created a main method, and in that we want to print, and then we're going to call the inPrintLine function, and what we'll do is we will we're going to pass message, which is hi, or it could be really anything. It could just be like this is the message, and then it's going to print that out 3 times. Okay, and so let's just save that and run it and see what it looks like. And yep, we've run it, we've printed it out 3 times, and we've gotten to the end. Now, what if we wanted to try, instead of this, we wanted to try to change the order that we pass to the order of the arguments. And so, say for example, the parameters that we pass to them, instead we want to pass in first, and then we want to pass hi second. Okay, let's see what happens when we try this. All right, so it's going to run. It's going to cause an error. Let me do this again. All right, so we see what happens is that it causes an error when we try to do this because it's not in the same order that this is expecting. It's expecting a message first, and then it wants an integer second. And so because we pass it in the incorrect order, it thinks that we have a string object here that cannot be converted or interpreted as an integer. So that's the problem that we have here. All right, so to get around that, so kind of to summarize that, what we need to remember is that arguments must match parameters in terms of their order. We just talked about that. Also, the number of parameters. So, example, if we tried to pass 3 parameters to the inPrintLine function, then we would also get an error because we would need an equal amount of an equal number of parameters. And then they also have to match the type, and we saw that before, is that the arguments must match the type. In other words, you can't pass a string whenever it's expecting an integer, just as we saw over here. Okay, so to kind of get around that, we can change the order of the arguments by using what is called keyword arguments. And the way to do that, again, we have the same function here. We can specify which arguments that we're passing. So here we can say n equals 3 and message equals hi. And what that's going to do is, we've changed around the order of the arguments, but we've just specified which is which, and we can pass them in any order so long as we say which they pertain to. So this is pretty simple. So if I run it, you can see we have the exact same output. So this is just something that you need to know, that you can have either positional arguments or you can have keyword arguments. All right, let's talk next. Let's talk next about what your book talks about, and this is what your book calls reference values. And so a couple of things to look at. Let's look at this little function here. We have a main method or main function in which we declare that the value of x is 1, and then we print out to the console before the call the value of x is, and then the number of x, so it should be 1. And then we call this function called increment, and we pass the value of x as an argument, and then basically we've called this method the increment method, and then we say within this, let's increment the value of x, or of n, what we pass to x as 1, and we say inside the function the value is, and it should be 2. And then when we get out of that, then we'll notice something interesting here. Whenever we try to look at the value of x, even though we've incremented the value of x, we'll notice something interesting. So let's run this and see what happens here. I'm going to comment this out. All right, so before the call, the value of x is 1, and then inside the function, n becomes 2, but you notice something interesting, that after the call, the value of x is still 1, even though we have told it to increment x. And the reason for this, very interestingly, is because in Python, numbers and strings are what we call immutable. In other words, they cannot change. They're always the same. And the reason for this is because whenever remember back in week 2, we talked about declaring variables in memory. When we reserve that variable in memory, it gets a pointer in RAM that allows us to point. It points the variable's value to a certain point in memory. And so because of that, what happens is we have to, whenever we assign a new number to a variable, Python will allocate a new object and store it in memory. So let's look at this bit of code. This is kind of interesting because what it does is it kind of helps us to understand exactly what's going on here. So we've declared x equals to 1, and then we want to print the ID of x, and this is the place in memory, or the number, the identifying number in memory that x is stored as. Okay, and then we say x equals x plus 1. Okay, and so we would think that this ID should be the same, but it's not, because we've changed x. It creates and allocates a new place in memory. And you'll see that when we run this, that when we try to print out the ID of X, that it's a little bit different. So let's look at this and see what happens. Okay, so the first thing is we've said X equals 1, print out the ID of X, and it returns this value, this object number in memory. And then we say increment it by 1 and print out the value of the ID of X. And we notice that these two numbers are different, and that's because whenever we have reserved this new value in memory, it stores it as a completely different object. So it's something that can catch you up if you're not thinking about it. You might be thinking, well, I incremented X. Why isn't it showing me the old value of X? It's because it's reserved in a different place in memory. So that's why it's really important to remember that sort of thing whenever you are programming. Another thing that your book talks about is modularizing code. And basically what modularizing code, easy for me to say, is that it allows us to store our code in different Python files. And so it allows us to create whole libraries of our own code that we only have to write once and then just reference later. As long as it's in the same folder, we can import that code and use it. Now you notice that in the past we've imported other modules within Python, and this is very simply we're creating our own module now, and we can use and import functions from different modules. So in this, this is the same maximum program that we looked at the very beginning of the chapter that compares two numbers. We've saved it in a function called maxfunction.py, and we've named the function max. Okay, so we've got this saved in a Python file, and say we have another, and we have it saved away on our hard drive. But say we are writing another program, and we want to be able to call this max function in this other Python file. Well, what you can do is you can say from the max function file, okay, from max function, import the from the max function module, import the max function, okay? And what this does, this line of code does, is it allows us to have access to this max function within this particular module. We can say what's the larger number of max, 5 and 6, and then print out the larger. And the cool thing that we'll see here is that whenever we run this, that it's able to access that other module to use the max function and compare the two numbers. Okay, so very, very powerful. What happens though if we decide not to do this little import? You'll notice then that we get an error because it's not, let's see. Although it's unfortunate it's in memory, but if we didn't have that max function, we wouldn't be able normally to access that. So remember to import that which you need. Okay. All right, now next, your book talks about this thing called variable scope. And we talked back in week 2 that variables all have a scope. In other words, variables only exist in the block of code or part of the program from where they are referenced. And so, for example, if you have a block of code and you declare a local variable within that function or that block of code, if you have another function, you wouldn't be able to know that particular, then Python wouldn't be able to identify or see the value of that particular variable because we have what's called information hiding. And so because of that, we can't access local variables outside of the local block of code. But you can do in Python, you can declare what's called a global variable that can be referenced from anywhere. And what global variables are variables that exist out of all of the code but can be referenced from within any function. So let's look at this little piece of code here where we declare a global variable called global var. We set it equal to 1. Then we define a function called f1 where we declare a local variable called 2. And then we say print global var and print local var. Okay, so from within this block of code, we should be able to access the global variable 1. Okay, and we can also see this local variable here. Okay, then we've created then what we said is invoke the f1 module. Okay, and then print out the value of global var. Okay, so let's run this and see what happens. Okay, and so what we see is that we printed out the value of global var, which is 1. I'm sorry. First, we've invoked f1. Actually, I should have done this first. Let's try this again. Let's get back up here. All right, so let's run this. All right, so we call f1, and the first thing that it does is it prints out the value of global var. It's able to access it externally because it is a global variable, and then print out the value of local var, which is 2. Now, say for example, we want to access. We want to print out. We're going to modify this to where we want to print out the value of global var from outside of this function definition, and we want to print out the value of local var. Well, it's in this function, so what's going to happen is we're going to get an error because it's not able to find the value of local var, and that's because local var is out of scope. It's inaccessible because it exists within another function. So if I try to run this, we're going to see what happens here. Right, and we get this error because it doesn't know that local var is defined because whenever we print in, whenever we try to get inside it, it's not able to see that particular variable. So something to keep in mind, that variables all have a scope, but you can get around it by declaring global variables. Okay. Final thing that we want to talk about in this chapter is the idea of a default argument. And sometimes you might want to provide a default value for an argument. And what this does is it allows you to call the function without arguments. Maybe you just have a common default value for an argument that rarely changes, or you want it just to have by default a value when you run it. So in this particular function, we've defined a function called print area. It's expecting 2 different arguments or 2 different parameters, width and height. And we said by default we want the value of width to be 1 and the value of height to be equal to 2 by default. And then we say we know that the value or the area of a rectangle is the width times the height. And then finally in this function we say print out the width, the height, and the area on one line. Okay, so by default, because we have default values for our argument, we can just invoke print area as a function, and it's going to automatically print out the default values for here. So I'm going to run it here, and it shows me it took the default value of width, the default value of height, multiplied one times the other, and then printed out the values here. Okay, easy enough. So another thing to remember is that you can use what we call positional arguments. And that is we're passing width first and then height. And whenever we pass actual values, then what's going to happen is that it will override the default values and it'll do our calculation. So let's save this and run it. And what it did indeed is it did override, and it passed width is 4, height is 2.5, and calculated the area of the rectangle is 10. Okay. Also, you can do keyword arguments. And what keyword arguments do is you can pass you can pass them in a different order than it's expecting. Normally it expects width first and height second, and then in this in our call here we've specified height first and width second, and as keywords it's still going to work, and it's going to say yes indeed that the width equals 2, height equals 5, and then the area is equal to 10. Now, final thing that you can do with default arguments, which is really cool, is that you can only pass you could only pass one argument. So say for example we want to only pass the value of width, and we say width equals 1.2, then what's going to happen is it's going to use the default value for height. Okay, let's see what happens when we run this. Yeah, we got to save it. Okay, so what happens here is we pass the value of width. Okay, and because we did not pass the value of height, it used that default value and as 2 measured, and then it multiplied 1.2 times 2 and calculated the area of the rectangle as 2.4. So, this is another way for you to have maximum flexibility. You might want to do this, like if you had a program that used division, you might want to say, say you had one called numerator equals 1, and you could say the default denominator is equal to 1. You can do that as a way to trap your error in case the user entered 0, and then you get a division by 0 error for the denominator. So there's just a lot of great use that you can have whenever you are want to be able to have default arguments or not pass all the arguments to the parameters for a function. So anyway, this is everything that we have for this particular week. If you have any questions, please make sure that you contact me. Remember, once again, midterm is next week. It's going to cover everything that we've covered so far in the class, so just kind of be ready, and we will talk to you later. Have a great week.